All right, so we're here to finish up chapter 8, which is just more equations. Yay! They're just going to get more complicated this week, and they are going to get fractions and decimals and all that fun stuff. So we'll see how much we can get through in one video. Might make two, depending on how long the first part takes. There's not a huge amount of problems, but like I said last time, just needs a lot of practice on your part. I really want you to have these equations under control before you go on to your next course. So we're going to start with 8.3, and that is called a general strategy for solving equations. And so these are just all kinds of equations. There's nothing special. They're not the one-step ones we were looking at before. Sometimes there's letters on both sides. Sometimes there's numbers on both sides. Yeah, we're just going to see what needs to be done in each problem. So for this first problem, 1A, I notice that there is one variable, that x, and then there's two constants. And so I'm going to move this 3 to the other side. That's my game plan. So let me get rid of that mess. And remember, the other side means we have this imaginary line down that equal sign. And to move, to move across it, we need to add the opposite. And so I'm going to add the opposite. I'm going to subtract 3 from both sides to get that 0 pair. 8x equals negative 24. I'm multiplying by 8, so I'm going to divide by 8. X equals negative 3. This is just supposed to be a nice little warm-up. You'll notice our warm-ups are getting a little more complicated because we're picking up where we left off in the last video in terms of difficulty. So these are now 2-step equations that we are using to just kind of recall how to do equations, and then we will move on to a little more complicated problems. So again, we have the green line down the middle to show us our left and right side. I'm going to add 11 so that I only have numbers on the left. Oh no, I'm sorry, we only have numbers on the right. So we have a negative 38 and an 11, which means we subtract those two numbers, put a negative, and then we have a negative 9x on the left. Divide both sides by negative 9, and we end up with x equals positive 3. We have those two negatives that cancel out, so it turns out to be positive. And finally, we have, now this has a fraction in it, so it does initially look complicated, but if we just do this one level at a time, we'll find out that there's not actually any fraction work that needs to be done in this problem. So I'm going to add 1, so I'm going to get the constants together, and I get y over negative 5 equals negative 10. And then what's really happening, instead of a fraction, we're really looking at division over here. So I'm going to multiply, because that's the inverse of division. I'm going to multiply both sides by negative 5, and I end up with y equals 50 as the final. Okay, so remember, we're just taking our time, getting through these equations, working through the steps, practice, practice, practice. There's really nothing new in any of this module. It's just increasing the level of difficulty of these equations. That's why I separated this into 2 separate modules. It's just because it gets more difficult, and difficult means more time consuming. Okay, so here we have, I'm just going to draw all my green lines at once, so I don't have to keep itching pens. Here is green line, do the equal sign. Probably stop doing this one of these days, but it's fine. Okay, so on the left side here, I have the negative 10x, but I also have an x on the right side. So I have 2 choices. I always have 2 choices. I can move them to the left, or I can move them to the right. Now the benefit of moving these to the right is my right side, that's not what I wanted to say. The benefit of moving these to the left is that I only have x's on the left. So if I add 5x to both sides, now I have all my x's together on the left, and I have all my constants together on the right, and now everything's all split up. If I had moved my x's to the other side, it would have just gotten more messy. I'm going to divide both sides by 5 and get x equals negative 1. If this is becoming quick and easy for you, which at some point it will, maybe you can do the next 2 or 3 problems pretty easily, and then it gets more difficult again as you're looking at F and you're like, ooh, that looks kind of hard. At any time, just pause it, see if you can do these faster than me, do them without me, and then come back and check your answers. And the more you can do by yourself without me, the better. Because again, I'm not teaching you anything new in this video. I'm only reviewing stuff we already know, but at a more difficult level. Okay, so let's try this again. I'm going to subtract 5x to get my x's together on the left. That gives me negative 8x equals negative 16. Divide by negative 8, and I get x equals 2. Now, see, we have numbers and letters all mixed up throughout this problem. So we need to make a choice. What side do we want the numbers on? What side do we want the letters on? And typically, people say they want the letters on the left, and there's nothing wrong with that. If I want all the letters on the left, I need to get rid of this 8x by subtracting 8x on both sides. If I want all my letters on the left, that is fine. Some people don't like that because they say, oh, that's a negative 11x. I didn't want a negative. Other people say, yay, it's on the left side. Nothing else matters. So it just depends on how you like to do it. If you did a different first step than me, if you added the 8 first, or you added the 19, or you did something different, that's fine as long as you end up with the same answer at the end. Okay, now that I made the choice to put the letters on the left, I have to put the numbers on the other side, on the right. I'm going to add 8. I have negative 11x on the left. I have negative 11 on the right. And so to finish up this problem, I have x equals 1. All right, that's it. Okay, moving on to D. I have, again, letters and numbers all mixed up. So I'm going to move my numbers to the left by adding 4x. Different order you work in, that's fine. The same answer as me in the end. Now I'm going to subtract 10. 7x equals negative 7. Divide by 7, and I get x equals negative 1. The last layer, we now have the distributive property mixed in with the letters on the left and right and all that stuff. So this will just take a little more steps. Now it'll take a little more time. I might end up running out of room. Try to cut it in the middle where there's more space. But remember, the left side, distribute to things in parentheses, and then we'll leave that 3 alone because the 5 does not go to the 3. It only goes to the ones in parentheses. Try that again on the left. The 6 goes to the things in parentheses. The 6 does not go to the 4. Next step, simplify by combining like terms. So my like terms on the left are the 2 constants. My like terms on the right are 2 other constants. So I have 5x minus 13 on the left and 12x plus 22 on the right. And now I'm kind of in a situation where I was before with C and D, where I'm going to move my letters and my numbers around. And so I'm going to do it backwards just because I can. I just want to show you that it doesn't matter what order you do it in. So if you really want your letters on the left, go ahead and subtract 12x right now. I'm going to subtract 5x just to show you that it doesn't matter. And so I end up with negative 13 equals 7x plus 22. I'm going to kind of move over to the middle because I'm running out of space. Divider line so we don't get mixed up. Now I'm going to subtract 22. And I get that 7x equals negative 35. And finally, x equals negative 5. The x is on the right instead of the left. That's a-okay. We just want to get that letter by itself. It doesn't matter which side it's on. Okay, so last one, definitely getting more complicated with these parentheses. Just always go back to that order of operations. And so on the left side, I'm going to take it one step at a time. I cannot do 2 minus 5 because this multiplication will come first. So that becomes minus 15x plus 5 because I have those two negatives there. I'm just going to keep going on the left until it's all simplified. I have the 2 and the 5 in the parentheses, so I'm going to add those together next. And finally, I'm going to multiply by 10. I'm going to distribute that 10 in there. And that's as far as I can simplify on that side. On the left side, it's only going to take me one step because I just have to distribute. So I'll just bring this down and I'll say 48 equals 36x. All right, now that everything's distributed, all the like terms are combined, I'm going to add 150x. Why? Because I can. So I want to do it backwards. Just see if you're paying attention. 70 equals 48. This will be positive 114x. And then we're just going to continue on by subtracting 48 from both sides. So I subtract 48. I still have my 114. I'm going to write it up here because I'm running out of room. I still have my 114 on the right with the x. And now on the left, I have 70 minus 48, which is 22. So the last step, I will divide by 22. And I actually end up with a decimal. So rather than dividing by 22, I'm just going to reduce this fraction. This 2, they're both even. 2 will go into it. So 114 divided by 2 is 57. 22 divided by 2 is 11. Oh man, I did this upside down. All right, hold please. Let me just erase. I should not have subtracted by the 22. I should have divided by the 114. 114 definitely does not go into 22, so this is definitely going to be a fraction answer. But since I already did the division, I can just redo that. 2 goes in 57 times, 2 goes in 11 times, and now we have our right side up answer, which is 11 over 57. Whew, that kind of got a little messy. Hopefully you're able to keep track on your notes. I always forget about the margins, so I don't use the margins enough. But you know, if it's getting too much, just rewrite it on a separate sheet of paper. Make sure you can understand it, because that's all that matters to me, is that you understand it. I'm not checking your notes to check every single number, because it's your notes. You know, you write down what you need to write down. Just write it in a fashion that you find organized, so that when you're taking the quizzes and tests, you have something to refer back to. Okay, so go ahead and do the 8.3 homework. Just going to have to do this one step at a time, one section at a time, because these problems will get quite long. And I'll take a quick break. And we are back. And now this section, I wrote 8.4a, but if you've looked at the module, you'll realize that what I wrote, what did I just say? I don't know, I think I just said it wrong too. This is what it should say. It should say 8.4 A. And then the last section in this module, 8.4b. So this is just the only typo right here. And so 8.4 is the equations we've been doing. However, now we have to mess with fractions. And so here we want to have a general strategy for solving equations with fractions. And that general strategy is get rid of the fraction. That is the best plan. So what I'm going to do, and this is going to get really messy at first, however, it will work itself out and it will quickly get cleaned up. So the rule is, unofficially, get rid of the fractions. And the way we want to do this is by multiplying by the LCD. Okay, so looking at this first problem, I have a 3, a 4, and a 2 as my denominators. And so I want to find the LCD of those three numbers. Oops. So I'm going to do that. What am I doing? I'm trying to erase all this. Okay, yeah, perfect. And so a 3, a 2, and a 4 will all get canceled out if I multiply everything by 12. And so what that means is and don't do what I did. You can do what I did in red, but make sure you do this next step as well, because this gets, people get problems wrong if they just, you know what, let me just erase it. Don't do that, that's terrible. What you wanna do is you wanna multiply everything by 12 like this. 12 times 1/3 x plus 12 times 1/2 equals 12 times 1/4. And the reason you want to do it this way is because we are going to reduce every single fraction and they're all going to go away. So 3 goes into 12 4 times, 2 goes into 12 6 times, and 4 goes into 12 3 times. And that leaves us with 4x plus 6 equals 3. Now, we're not done. However, you might have noticed that we have a much simpler looking problem, meaning I don't have to add fractions, I don't have to subtract fractions, I don't have to multiply fractions, any of that stuff. So what we want to do is get rid of all those fractions and now solve it like we did in the previous section. So I'm going to subtract 6, get 4x equals -3. And you know what, we're going to get a fraction answer, but we're dealing with fractions, so that's kind of to be expected. Just rewriting it because I want to divide by 4, and I get that x equals -3/4 as my final answer. That's it. I don't need to go back and do anything. I don't need to change anything back. I multiply both sides by 12, every single fraction, every single term by 12, and I'm done. All right, number 2. Number 2, the LCD is 2 because all I have in the denominator is the number 2. That is the theme of this problem. So I'm going to multiply everything by 2. Now, the last problem only had fractions. So you might have made up a rule in your head that you're thinking that I'm multiplying the fractions by 2, but I'm actually multiplying everything by 2. I'm distributing this 2. And it doesn't matter if I just kind of wrote it backwards there. That doesn't matter. You can write it in the front or the back. But the point is that everything has its own 2. So on the problems with fractions, the 2's will cancel. And I'm just left with, in those 2 spots, a 3x and a 1x. On the parts where there's just numbers, nothing will cancel because there's no fractions. So we have 2 times 4 is 8. 2 times 4 is -8. And now, again, I have this 2-step problem. So I can subtract x or subtract 1x, however you prefer to write it. I can subtract 8. And finally, divide by 2 to get x equals -8. Problems with fractions don't guarantee answers with fractions, but you'll see it a lot. Problems without fractions doesn't guarantee answers without fractions, but you'll see that as well. So anything goes in terms of the answers. Okay, moving up to number 3, we're still solving equations with fractions. Now, this one's a little different because I have a distribution that needs to be done. And I'm just gonna look ahead and I could see that half of 2 and half of 4, you know what, that's not really the worst fraction that we've done. We can take half of those numbers because they're even. So I'm gonna distribute, and half of 2x is x, and half of 4 is 2. And just by distributing, I was able to get rid of all the fractions. So we don't always have to multiply by the LCD. Sometimes, I'll leave that as one step. Another step is to distribute, which is what we did in number 3. And so sometimes just distributing gets rid of the LCD. Gets rid of all the fractions. And so now I'm going to subtract, no, I'm going to add 2x. I like mine to be positive. So I typically move things to make them positive once we get to the point where we don't care anymore and everyone's doing their own thing. I'm going to add 2, which gives me 3x equals 8. Divide by 3, I end up with a fraction answer, 8 over 3. You want reduced fractions, definitely as your final answer if there's a fraction involved, but do not worry about mixed numbers. Improper fractions, improper reduced fractions are the best way to go. All right, finally, I'm going to distribute like we did before, but that doesn't always make good things. So I distributed, and I still, in fact, I actually have more fractions. I feel like we just made it look worse. But if you go back to the beginning of the section, you'll remember, you can hear me say, sometimes we're going to make them messier, but then the mess will go away pretty quickly. So what I want to do here is I want to multiply by the LCD, and I have 2 and 3, so my LCD is 6. In fact, let me just go back and write out the LCD, just in case you're reviewing this later and you can't remember what we did. So number 2, the LCD was 2. Number 3, we didn't worry about an LCD. And number 4, our LCD is 6. You don't remember what the LCD is? Go back to, I believe it was chapter 4, and maybe even the end of chapter 3. I think we did a little bit with least common multiples, or to get ready for least common denominators. That's one nice thing I have to say about this online format, is that you have all the lectures right there. So if you forgot how to do something, you can just go back and watch it. And you don't have to worry about missing a day because you just watch it on your own phone. I think I'm getting used to it. All right. Anywho, here we have our LCD of 6 that I multiplied by. So I'm going to reduce. Now, before, or this will be like number 1, where we reduce and then we have some numbers left over. So 2 goes into 6 3 times. 3 goes into 6 2 times. And so we get 3x minus 21 equals 2x minus 2. I'm going to subtract 2x. No fractions here. Look at this. We're going to get 1x only. Then I'm going to add 21. And we get x equals 19 as our final answer. All right. If you want to pause it, great. 8.4b is the same thing, but with decimals. So I'm just going to go through this. It's a quick section. It's just these 4 examples. But again, if you want to pause it, go ahead and pause it. I'm not going to put up the slide because this won't take too long. Because decimals aren't really so terrible. Fractions seem to be terrible. Decimals seem to be doable. And so for number 1, I'm going to add 7, just like I would do in other problems. And then I'm going to divide by 0.6, but dividing by 0.6, yes, you can't do it in your head. However, it's not, it's very calculator friendly. Dividing by fractions and fractions divided by fractions is really hard to do on the calculator. And so I try to just get rid of fractions. But here I plug this in, 15 over 0.6, and I get x equals 25. That's it, done. Not too bad. Try that again. Add 1. 3x equals 12. Divide by 0.3. Now you could try this in your head because you know 3 goes into 12 4 times, but it gets a little tricky with that decimal placement. So I like to double check on my calculator, and I end up with x equals 40 as the final answer. Okay, 3. We have some distribution, some simplification first before we do this, before we solve it. So I am going to have my 12 hundredths x plus 2 hundredths x plus, and then I need to multiply 2 hundredths by 2, so that's 4 hundredths equals 18 hundredths. And actually, that's a lot of hundredths. Everything's hundredths. So you know what would happen if I multiplied everything by 100? This is what would happen. Move it over 2. I'm going to do that in a different color. Try it again. Move it over 2. As long as I'm doing the same thing to everything, it's allowed. So if I move the decimal over 2 places for everything, then I end up with 12x plus 2x plus 4 plus 18. Was that necessary? Well, if you have a calculator, it's not really necessary because y'all don't mind adding and subtracting on the calculators with decimals. But if you don't have a calculator, it sure makes it a lot easier to look at, because now I can see 12 plus 2 is 14x. And then I can subtract 4. So I get 14x equals 14. Divide by 14, and I get x equals 1 as my final answer. Just like with the fractions, as long as you do the same thing to everything, I move the decimal over 2 places for everything, then I'm fine. I don't need to go back and do anything to my final answer. So x equals 1, that's it. All right, moving right along. We have 25 hundredths, and then we're going to multiply it here. So 25 hundredths times 100, I'm distributing. I get 25x. 4 times 0.25, well, that's just 4 quarters. We know that equals $1. On the other side, I have 3/10 that I'm multiplying times 20 for 6x. And finally, 3/10 that I'm distributing also to that -60 for -18. And just like with the fraction section, sometimes you just start the problem and everything goes away. All the stuff, all the bad stuff goes away. So I actually have no more decimals. I don't need to worry about anything else in this problem except solving it. So I will subtract 6x. And then I will subtract 1. And finally divide by a positive 19, which gives me a final answer of x equals -1. So the moral of the story is practice, practice, practice. This section, all of chapter 8, it just gets easier over time and with more practice. So like I said in the last module, if you get stuck at any time, especially look at how complicated these are. These decimal problems, and then scrolling back, look at what a mess we made. That's going to be a lot harder for me to guess what you did wrong if you send me a wrong answer. So don't say, I'm having problem on number 25 or something like that. Just, you can send me the problem, or even better, take a picture of your work and send it to me, and then I can look at what you did, and then I can get you back on the right track. So practice, practice, practice. And if you sneak peek looking down at the next module, Introduction to Problem Solving. So we're going to be moving on to word problems in the next module. So enjoy this section enjoy this module while it's only a couple of
sections long. All right, I will see you in the next video.